TypeScript is awesome. I don't think you need me to tell you this. It basically has won the browser language wars, and I personally have been using it since they first announced it back in 2012. The type system that they introduced was just an absolute godsend for people like me that were just starting to take JavaScript seriously again. But TypeScript does have one fatal flaw that can be a bit of a gotcha, particularly for new coders. So let's take a look at this example to show you what I mean. So here we can see we have a TypeScript user data type, which has an ID of a number, username, age, and is active. And then we have down here an Express server. So this is just a standard Node.js Express server that has a single post endpoint here. And we are taking the request body in and we are casting it as a user data. So we're saying that this user data, data that's going to come in from this request is going to be of type user data. Now, the problem is, what happens if it isn't? What happens if the data that comes in doesn't look like the user data at all? When we actually come to use it, we say there's a username, perhaps the username is missing, was a null or different value, and we try and do 2 uppercase on it, we're going to get a runtime error. We're going to get a type error, cannot read property 2 case of null. So we can see there's a problem here. We lose our lovely TypeScript types that we have carefully crafted in here, and they all just go away at runtime once the TypeScript gets compiled down to JavaScript. So what we need really is we need a way that we can take our TypeScript types but still use them at runtime to do our data checking. So we can see that our TypeScript type system here didn't save us because the TypeScript code is compiled away and all those lovely types just disappear. So TypeScript is only checking types at compile time, which means that we have no runtime type checking at all. So this can lead to a common issue where we think our code is safe, but it can still crash with unexpected data comes in at runtime. Now, there are many libraries out there that do this, but a current crowd favorite is one called Zod. Zod describes itself as TypeScript first schema validation with static type inference, and basically sounds exactly what we want. So let's take a look at our example again, but this time we'll bring in Zod. Okay, so we have our Express server as before. We define it up here, and then we have our post endpoint here. Except in here now, it looks a bit more different. We have a bit more code. So the first layer here, what we're going to do is we're going to take in our request body and we're going to pass it to this user schema validator. And that is defined down here. And so we're saying a user schema is going to be an object that's going to have some properties on it. And these properties are going to have specific types associated with them. Pretty simple. So now up here, if we try and parse our input data and it doesn't match one of these validators, these nested validators here, we're going to get an error, and then we can just return a nice 400 message to the user and potentially even return some more information about exactly what they got wrong. But if it passes, if this validation passes, then we are pretty sure that, well, we're certain that this username is going to be of string, and so we're much more confident now that our code is not going to suffer some runtime issues. And one other thing I also wanted to show is that we can actually add extra, you might have noticed extra validators here. So we can say that username string must have at least 1 character in it, and the age must be between 0 and 120. So this is great. This means that we can add much more restrictive structure around what we expect our data to be at runtime, which is, yeah, really, really nice. And one other property of Zod and other runtime type libraries is that you can actually infer the TypeScript types from the runtime validator structure. So for example, say I had a function here where I wanted to process this user here. We want to get this user from this user schema, so we can have a strong type at compile time as well using TypeScript. And we can do that using this little helper from Zod where we infer the user schema. So we now know that the user is going to be ID number, string, age, and have a boolean on it, which is what it matches here. So it's the best of both worlds. We get our TypeScript types at compile time and we get our runtime validation at runtime. Brilliant. So it would be a bit remiss of me if I didn't talk about how Convex fits in here. So although you can use Zod on Convex using some helpers, Convex actually has its own built-in small runtime type validation library. So let's take another look at an example and see how we would use Convex's built-in validation. So here we have a Convex example. So we have at the top, instead of our Zod user schema, we have this very Zod looking runtime type schema, but using this V, which comes from the Convex values library. So we define an object, username is string, age number is active. And then we can use it in a Convex function, like a mutation, like this. So we declare that we expect the args, the arguments to this function, to be of this type. And it's not only just the type, so we get the type, types here, but it's also going to validate it before this function even runs. So we get a really kind of nice built-in validation for us. So we know that every single Convex function, as long as you declare the args like this, is going to have its input validated for us. And I should also mention that if you want to declare what the output is going to look like, we can just say returns and then another validator like this. So in this case, would look like this, and we could say return user created and then the ID of the user that was created like this. And then if we were to return a number, for example, like this, we would get an error because TypeScript's going to compile at us. Also, if we were to like say as string, for example, as any, maybe as any as string, then we're kind of like tricking TypeScript into thinking that it's going to be returning what we expect, but we're going to get a crash at runtime and we're going to get a nice error that's going to tell us why it's not returning what it should be returning. So that's nice if you're dealing with like dynamic types and things. And just to close the loop, from the client side, we have this React component here. We can use our mutation using our use mutation hook from our Convex React library, and we can pass in this object which is generated for us when we run Convex.dev, and we get back this create user function, which allows us to then call our mutation from the front end. And because we're using a runtime type validation, we get nice type safe API here. So the username is expected to be a string. So if I was to put a number in here, TypeScript's going to yell at us. And the same, like if we were trying to trick it, make it a number. Then when we try and call that function, it's going to check the type and going to return a runtime error with some nice error message for us. This approach of using runtime type validation, whether through Zod or through Convex built-in validation, gives us tremendous confidence in our code's reliability. We know that our functions will only ever receive and return data in the exact shape that we expect, which significantly reduces the likelihood of runtime errors. And as your codebase grows and becomes more complex, having this validation in place becomes even more valuable. Basically, it allows you to catch potential issues before they can cause problems and provides clear, actionable error messages when something goes wrong. And perhaps most importantly, this kind of validation can reduce the number of tests that you need to write. And since we're validating the shape of content and data at runtime, we don't need to write extensive tests to verify our functions handle different types of input correctly. The validation system does this all for us automatically. So thanks for watching. I hope this explanation of runtime type validation has been helpful to you. If you want to learn more about TypeScript, Zod, or Convex, you can find relevant links in the description down below. And if you like this video, don't forget to hit the like button, subscribe to the channel for more technical content like this. Until next time, cheerio.